In the last few years, we experienced increasing demand of gallium-68 for research purposes and also for clinical purposes.
We have already a considerable experience with PSMA gallium-68 PET-CT in patients with prostate cancer for the past 2.5 years. And we have already performed several hundred diagnostic procedures. With the PSMA, we have the advantage of getting a whole body image where we can see and have a better understanding of the overall disease burden, irrespectively of the organ affected.
Our life became hard with the generators. It was not cost efficient. We could only take through 2-3 doses a day. We made a big research project together with the IBA to optimize the production of gallium-68 from a new target, a new liquid target.
Collaboration has been set up with IGNAS, based in Coimbra, Portugal, and we develop a complete solution for gallium production, starting with liquid target. So in that field, we start with the target on cyclotron up to the solution ready to be injectable.
Everything starts as the cyclotron, where you have the irradiation and enriched zinc solution. After that, you have the chemistry part, the pause process. This pause process is performed with the Synthetic extension in 2 steps. After that, you have the final labeling that can be done either with a cold kit, a lyophilized precursor, a peptide, or with the synthesizer for the labeling of different types of peptides. This whole process, all the way from the irradiation of the cyclotron up to the labeling, is patented.
With this process, we could create a methodology of making gallium in a daily basis, 3, 4, 5 productions a day, to fulfill all demands. We are now in a position to do it for clinical, to do it in a much more cost-efficient way than a generator. It can easily be set up in any existing center. When we have a high-yield cyclotron with high-yield targets, we can produce all the FDG that we need during the night, and then during the day we have time for research.
With PSMA, we can also perform theranostics, because instead of targeting PSMA with gallium-68, if we target it with lutetium-177, we can actually image and treat the patient with the same molecule, just changing the isotope.
We are very happy to see how useful it is, how it grown our research capabilities.